Okay.
Greenbrier Lot is notorious for being a dark place on campus where theft most frequently occurs. Students walk there at night without a sense of security because of the poor light quality there. Me and my teammate, Hyun, wanted to develop a way to increase the lighting quality in several of Rice's parking lots while also saving the Rice money and reducing our environmental footprint. So today I'm going to walk you through the logistics of assessing this business plan, determining how to implement it, and then I'm going to present our financial results. My partner, Hyun, is going to talk about our environmental impact and some challenges we came across while working on this project, and then finish off with future recommendations. The LEDs are becoming increasingly affordable. You know, each year the technology is constantly improving. And so they're better. They're good because they reduce energy consumption. They also reduce maintenance costs. Unlike traditional light bulbs, you know, LEDs don't need to be replaced frequently. They only need to be replaced once their lifetime is over. Several retrofits have already been implemented across campus, such as Lovett Commons and Herring Hall. And so the logistical expertise needed to implement an LED retrofit already exists. We simply wanted to provide a financial and environmental impetus for implementing an LED retrofit in Rice's parking lots. And so Rice's parking lots currently use mostly 400-watt high-pressure sodium bulbs. So our first step was to determine the scope of our project. So we ended up choosing to look at North, Greenbrier, and West lots 2 and 3. West lots 1 and 4 are right across from Shepherd, and there's impending construction plans there. So rather than install LEDs where the lights might not be in a couple of years, we decided to avoid that lot and focus on these. And so from our, we learned that there were 20 total fixtures in all these lots. So some poles have 1 fixture, some poles have 2. So there are 20 total fixtures in these lots. And we're trying to convert these fixtures from high-pressure sodium, like I said before, to Lithonia Lighting's DSX LEDs, which is sort of a LED standard that was given to us by Jason Hochstein, a senior electrical engineer for users on Rice's campus. And then, you know, after deciding, you know, which sort of LED we want to replace the current lights with, we analyzed the economics of the situation. And this is actually a map of Rice's lighting that I got from Rice's architectural historian. So we made several assumptions with this project. We assumed that the lights were on for 12 hours per day, which comes out to 4,380 lights hours per year. There are 20 fixtures, and we saw that next year the projected electricity cost was 7.5 cents per kilowatt hour. We wanted to use a 10-year average, so the 10-year average electricity cost for Rice was 10 cents. And so our total energy savings switching from high-pressure sodium to our LED lights will be 32,000 kilowatts per year for all 20 fixtures. Our capital investment was about $18,000, and annual savings were $3,200 a year, and our payback period was almost 6 years. And so if you look at the luminaire output, we're assuming a 1-to-1 ratio for high-pressure sodium to our LED lights. The high-pressure sodium lights emit about 8,000 lumens, and our LED lights emit about almost 4,500. What you have to understand is that the quality of these lights being emitted is different. So LED lights emit a wider spectrum of light than the high-pressure sodium do, and so they interact with the surroundings very differently. And so you can have a lower lumen output, but still have higher quality lighting in an area. I'm now going to hand off the floor to my partner Hyun to speak about our environmental assessment.
Before I go into metrics for environmental assessment, we will first look into permits and regulations we have to face before starting the project. Mainly, All of them were based in Rice because the lights were based in Rice, and there were also retrofitting going on at Rice. And the first place we looked into is a Rice Parking Management, a third-party venture which is in charge of all the business, budgeting, planning, and organizing for any events related to parking. We talked to the director, Mike Morgan, about retrofitting into LED lights for the parking lot areas. He was very interested and actually had done some retrofitting in his garages with other lights. And he showed interest and wanted to see if it was profitable on the return. We also went into FEFP office, the Facility Engineering and Planning Office, who's in charge of major equipment that relate to electricity. We talked to the electrical engineer, Jason Hochstein, for advices, and he gave us some really good guidelines that helped us move our project forward. Rice Administration, obviously, is the last approval we'll have to seek out. They might be considering campus unity as a whole and aesthetics, and be against the idea of partial installations of high-pressure sodium lights. However, since LED lights provide more crisp and brighter environment, the whole campus retrofitting, our further recommendation, would push them to see this as a potential business proposal. For environmental metrics, we considered one major part of environmental impact instead of three, which is ecotoxicity, air respiration. We focused on the global warming aspect because the proposal scope specifically asked for carbon dioxide emissions, and global warming analysis would provide a bulk of it. Also, from life cycle assessment, we assumed that the usage part was 10 times more significant than other parts combined. So we also focused on the electricity consumption of our life cycle assessment. And by doing that, we saw 35,000 kilowatt hour of natural gas for high pressure sodium, which correlates to 42,000 pounds of carbon dioxide emissions per year. And LED lights, which is 3,100 kilowatt per hour, corresponds to 3,700 carbon dioxide emissions, which is a savings of 39,000 pounds per year of carbon dioxide emissions, which is about 90%. And there are multiple assumptions and uncertainties in this calculation. As I mentioned earlier, we only focused on the global warming aspect instead of ecotoxicity and respiration, since our focus was on the carbon dioxide emissions and greenhouse gas. We also assumed manufacturing factor negligible because we knew that the bulk of the carbon dioxide emission came from the usage part, and the margin of error created by discounting this factor would be around 10%. Disposal cost was assumed to be zero sum after reselling of the material. LED lights have aluminum heat sink attached to it, which catches the heat, but which will need recycling in the end. However, the recycling cost could be offset by the reselling of the metal, and we just assumed it to be negligible. There were a few challenges to this project. We did not have the full expertise in light designing, so instead of focusing on floor candles, which are lumens projected into the area, which actually matter, and simulations programs that could run these are pretty expensive and were out of our budget. So we sought expertise from Jason Hochstein, who had experience in these areas and had these simulation programs available. And we would conclude that further collaboration with him would enhance and solidify our project to be a more comprehensive design of light designing. And there were uncertainties in certain parking lots, such as North Lot and West Lot. We heard that West Lot was going to be renovated, and a new building in an area of West Lot will be made in a couple of years. So we took care of that by having a partial installation of West Lot, such as West Lot 2 and 3, which will remain unchanged at least in the course of 5 to 10 years. So I would like to point out again our main points for this project. For our annual energy savings, we saved up to 32,000 kilowatt per hour per year, which is from 35,000 to 3,000, just by changing 20 fixtures of parking lot lights. energy saving costs were up to $3,200 a year, and the greenhouse gas savings, mainly CO2, was reduced by 39,000 pounds per year, and really closed down the carbon footprint for parking lot lights. We would recommend that actually the whole campus to be retrofitted to LED lights because there's a lot of potential in environmental and energy savings, and as the group before us showed, that even like dormitory colleges retrofitting would save a lot, just one of them, and having the whole campus retrofitted would save us a ton of money, and a lot of carbon dioxide footprints would be cut off. And these are namely parking lots, parking garages, buildings, dorms, and even street lamps in and out of Rice. And this would get a big picture of Rice taking initiative for green energy and promoting it. And we would like to thank Professor Cohan, Jason Hochstein, Professor Johnson, Mike Morgan, John McGrath, and our cell members for their continued support and guidance for our project, and we would like to open up the floor to any questions you got.
So, similar question to the previous group. Walk me through your calculations of maintenance savings. How much time do you think maintenance is going to take? Did you talk to Mike Morgan about what's involved in that process, or to Jason Hochstein?
So yeah, I talked to Mike Morgan about it. He said it would need something, you would need like a cherry picker to bring that up and change the light. We didn't factor that into the payback period or capital cost calculations. So could you?
Oh, so the savings that you calculated are energy savings.
Yeah, totally.
Okay, so they don't include the cost of having someone go out there with a lift and make those replacements.
I think it's sort of a counterbalance by the fact that you replace high pressure sodium light bulbs, but you never have to replace LEDs.
For environmental assessment, I did analyze the life cycle, and it was at least 4 times more. The LED lights would last 4 times longer at least, and we actually assumed for our LED lights to last up to 20 years, and in the course of 20 years, the high pressure sodium lights would have to be at least switched out 3 times, while LED lights we would only do it initially. And from that, we would expect more savings in the end, and to our benefit. So it's good.
I think the maintenance cost savings to parking would be quite meaningful. Not to mention the hassle that's involved in that. Those aren't easy bulbs to replace.
So was your project, you might have mentioned this, but was it just to replace existing light fixtures, or were you going to suggest any new light locations in the parking lot? Because I know you mentioned at the beginning that Greenbrier has adequate lighting. So.
We're just replacing existing light fixtures.
Okay.
And so with this specific type of LED, you can use different light distributions to provide like more of a gradient, less contrast, so you're not walking in like a really brightly lit area and you can't see anything beyond that. And so there's a lot more flexibility using this specific type of LED and lighting.
Yeah, I think at the city of Houston, as they switched out the lights to LEDs, I mean, they're a lot brighter. My street is so much brighter now. You can tell a difference.
Yeah, I wonder, another way to strengthen this case is just to look into public health studies and how much LEDs can change crime rates. Interesting.
Nice. But what was the payback on this project? Like how long was it?
It's 5.6 years now.
Okay.
From the specification sheet for the specific type of LED, it said it'd be like 100,000 hours, which is around 23 years. So,
did you compute other metrics, net present value or rate of return or anything?
I don't think we could.
So payback time was your main metric. Let's thank the team.